Okay, so now we got a safety FE type question, and we know this is applicable to the environmental and possibly the civil FE exam. So we know for the environmental FE exam under the health hazardous and risk, this is under safety, so we have to know about this stuff. Specifically in this case, the noise exposure levels based on the OSHA regulations. And we know for the civils, there's going to be that safety part in the construction section for the methods, construction methods. So we know this is also applicable in terms of safety on a construction site. So you might possibly see this as well because it's related to that safety on the construction site, specifically again, noise exposure safety. So what we have in this case is a two-part question, and for the first part we're looking at a conceptual question, and the second part is a calculation based question. We have a conceptual question here. So let's read that. So we're told based on the OSHA permissible noise exposure limits, which one of the following is not permissible by OSHA? So the one that's not permissible, meaning that 3 of them are permitted and 1 is not. So how would we do this? So if we look at the first choice, A, it says 105 dPA. dPA just stands for decibels. And that's what we use and as a units of measurement, decibels. And this A is just saying it's adjusted to human hearing, right? It's adjusted to what we hear as a weighted average. So to what we hear, that A is adjusted, right? So just that dPA, just think of it as decibels, and that's what we will look at in terms of those OSHA regulations. So this is saying 105 dPA, decibels, noise exposure for up to 1 hour without hearing protection. So now you're thinking, okay, how would I answer this? How would we answer this? Using the FE Handbook. So the goal here is to make sure we know how to apply the equations in the handbook and how to use the tables. So what I want you to do is go under this section where I brought it here. It's going to be the permissible noise exposure for OSHA. So it's in the FE Handbook, and you can do Control-Shift-F or Control-F, make sure to spell it right, permissible noise exposure, and go under that section. So we know this is in the NCS new FE Handbook, and what we have going on is this table. So we'll get to this, but the table here is important because it gives us that noise level, it gives us the noise level, and it tells us the permissible time, right? So for example, for a 95 noise level, the only permitted time we have is 4, right? So if an employee is in a factory and the factory, they hear a 95, let's say from an equipment or a machine, the noise level measured is 95 decibels, the permitted time that employee or worker is allowed to stay there is 4 hours. After that, hearing loss begins, right? The employee can suffer from hearing loss. So this is all this is saying. So let's say for now, this is like interesting. Let's say it's 130, which is very, very high, right? This is something we do not want to get exposed to. So the time here, the permitted time is so little, right? This is in hours, right? And if we convert that to minutes, so you just take that value and multiply by 60, because we know 1 hour is 60 minutes. So if I do that times 60, you get 1.86 minutes. So that one is very, very small. So if a worker in the factory is exposed to this, the noise level, they're only allowed to have a permitted time of 1.86 minutes. Anything after that, permanent hearing loss can occur, right? So that's what this is saying, and this is how we will answer that question using that table. So in that case, let's go above. We know that for example, in this case, the first one, 105 decibels, noise exposure for up to 1 hour without hearing protection. So without using any hearing protection, for 105, it says, is it 1 hour? Are they permitted exposure for 1 hour in terms of time? All we do is check that table. All we do is check the table. 105 is here, 1 hour. So that one is correct, right? That one is correct without using any hearing protection. So that one's correct. So we eliminate that because we want to find the one that's not permissible, not allowed, not permissible. So this one, 120, noise exposure, 7.5 minutes or less without hearing protection. So that 7.5 is in minutes. Note that it's minutes units, and it says or less. This is saying the maximum is 75 minutes Anything below that is okay, which logically makes sense, right? Anything below that maximum value of exposure time or less, anything below that 7.5 minutes is okay. Anything above that is not okay, right? So now let's look at that 120. Let's find 120 in the table. So finding that 120 here, it's going to be this, but that's in hours. So we have to be careful and convert that to minutes because it tells us the answer choice in minutes. So we do 0.125 hours, and we know 1 hour is going to be 60 minutes. So these cancel. So you just take that value times 60. So if I do that, I get 7.5 minutes, which is the one we have in the choice. So that is correct, right? So that one for 120 of the decibel for noise exposure, it is actually 7.5, right? So that one's out. So now this one, 95 for exposure for up to 8 hours without using hearing protection. So for 95, let's check that. 95 in the table. 95 is here. It says 4 hours. So that one is actually not true, right? And that's the one, that's actually the answer, right? It's not true because for 95, the permitted time is 4 hours, not 8 hours. So the maximum is 4 hours. If it was below 4, we're okay. Maybe 3 hours, 2 hours, we're okay at that noise level of 95. But for 95, it has to be 4 hours, not 8. So for 95, it has to be 4 hours, not 8. So in that case, for 95, the way we would correct this, it has to be 4 hours. 4 hours without using hearing protection. And if it was 8 hours, just know if it was 8 hours, you would just go down and find the 8, and it would be 90. 90 in terms of the noise level that we're allowed to receive, right, in decibels. So for 8 hours, it's 90, but in this case, we're looking at 95, so it should be 4 hours, not 8. That's actually our answer. Let's just check this. 85, 16 hours. So 85, go down. So for that, yes, it is 16. That one is true. So if it's true, we just eliminate that, right? That's not permissible. That is permitted, so that one's okay. So the one that's not true, which is not permissible by the OSHA regulation, is going to be C. So now let's dive into this one. So this one is a calculation-based question, and it's kind of tricky because you have to use the equation. So you have to use the equation, and that equation can be tricky because you have to also use the table as well. So what we're told here is a worker operates a machine for 8 hours a day. The worker is exposed to 85 decibel noise when the machine is operating at low speed, 100 decibels when the machine is operating at full speed, and 80 decibels when the machine is idle. The noise level with the corresponding exposure time is presented in the table below. The total noise dose the worker is exposed to is most nearly what? So we want to find what? The noise dose. So let's state that as what we want to find. Find the dose. And in this case, we're looking at noise. And we want to find that noise dose. And how would you do that? How would we do that to find it? So for the solution, how would we arrive at that? Using the noise dose equation, right? Using the FE Handbook on that page, on that same page in the handbook, under permissible noise exposure by OSHA, the Occupational Safety and Health Administration, the noise dose is this. And it says noise dose D should not exceed 100%. So it should not be bigger than 100%. Meaning here, if you look at the very bottom, if you look at the sentences they give you at the bottom below the table, it says if D is above 100%, noise abatement is required. This means you just have to employ some noise abatement techniques or noise reducing techniques or conversation programs and so on. So noise abatement meaning you have to like absolutely reduce that noise. You either shut down the equipment, you have to do something that eliminates that noise to make it below that 100%. So to make it below that. But if we calculate the dose to be 50% to 100%, you employ a conservation program that's required, a conservation noise reducing program. If it's in this range, right, 50 to 100%. But if it's 100 above 100, you have to absolutely reduce that noise. You either shut down the equipment, you have to do something about it, and to make it go down below that 100, right, that D value. So here it says no, D is 100% equivalent to 90 decibels time weighted average. So we know that D value at 100% is equivalent to 90, and that 90 we know is for 8 hours, right? Exposure time, the time weighted average. So this time weighted average is like, there's an equation for that, but it's not in the handbook. But just know that when D is 100%, it's 90 in terms of the noise level. So what this means, if I look at the table here, so when D is at 90, this is saying when D is at 90, it's 100%, right? This is when the D value equals to 100%. So it's with respect to that level, it's with respect to that 90 that we measure, that we compare the D value we get. So this means that if we are below 90, which is going to be this way, 85 and 80 is below 90, the D value is going to be what? It's going to be less than 100%, right? Less than 100% when we calculate it. So we're okay with that. We're okay in terms of not having noise abatement, like not shutting down something and so on in the factory to avoid that noise. But here, if we calculate D to be above 100%, we know that in that case it's above 90, right? It's 95, 100, 105, and so on. And that's the TWA, the time weighted average value, is basically these values that we can calculate using an equation, which is not in the handbook, just note. But just note that the biggest thing, D is 90, that's the level we start from, and that 90 occurs for 8 hours. So if we are less than 100%, it's going to be around 80, 85, and so on. Anything less than 90 is going to be less than 100%, and anything above 90 here is going to be above 100%, above 100%. So that's going to be that, and that's what they're talking about in that regard. But here it says the hearing conservation program is required if we employ that, and note we employ that when we have a D value of 50% to 100%, and you just test an employee hearing, providing hearing protection at employee's request, and monitoring the noise exposure. Then we know exposure to impulsive or impact noise should not exceed 140 decibel sound pressure levels. So anything that's like high impact or impulsive should not exceed 140 decibels, never, based on the OSHA regulation, which is like very high, like way down here. And we know those like impacts actually occur in like seconds. So even any type of exposure should not be permitted if they're 140, right? If it's above 140, at 140 and above, right? So that's going to be that, and that's also in the handbook. Just note that's in the handbook. So going back to this, I want to go into this equation and apply it and use the equation to actually solve the question here. So let's write the equation. We know D equals 100% times the summation. We take CI divided by TI. So now CI, it says CI is the time spent at specified sound pressure level. So that's the time we actually measure, right? The time spent, the worker spends, the time spent. And that's actually in the table, right? Those times are given. Then TI is, that one's tricky. It's the time permitted, and that's going to be permitted. So that's going to be the permissible time, right? That's the time we get from the table. That's the time we get from the table. So what I'm going to do is label these. So we know here we have how many? We have 1, 2, 3. So the first one, the 85, once again, is when the worker is exposed, when the machine is operating at low speed. So that 85 is for low speed, right? Low speed. And that 85 is going to be, let's call it the measurement 1 that we have. Then 100 is when it's at full speed, right? This is when it's at full speed. Makes sense. It should be higher in terms of noise level. So that's 2. Then when the machine is idle, here it's 80. So idle is 80. That's 3. So now the exposure times is actually what we want. Those are, this and this are units of time. So this is going to be the exposure time, and that's what we're going to put on top, right? That CI value. So that CI value is what we put on top. So this is going to be, CI basically stands how many do you have, right? That I stands for how many data sets do you have. So in this case, this is C1, this is C2, and this is C3, right? C1, C2, C3. So we take the summation of all of them in terms of C's. So now TI is the time permitted, right, on the bottom. So the time permitted for what? For what noise level? For these, right? We have to find that time permitted for those. So what I'm going to do is just extend the table and say the time permitted is going to be, we can just find that and put it in this table, right? So we know T1, the time permitted for this noise level of 85 is what? So you just go to that table, 85 here, it's going to be 16. 85 is 16. So I'll just do the rest in the table just to show you. 100 is going to be this one, it's going to be 2. And the last one at the very bottom, the smallest one of 80 is going to be 32. So that's what the time we will use, right, in hours. So keep the units consistent. These are all in hours, so these have to be in hours. So once again, T1 for 85, using the table, is going to be the 16. So that one is 16. And then for the 100, that's going to be T2. That one's going to be the 100. When you look at that, it's going to be 2. And T3 is going to be the 80. And that one should be the 32 from those tables. So 16, 2, and 32. So now we plug everything in. So D equals 100% times. So I'll just break this down and denote that as the summation. When they talk about the summation, so you have the C1 divided by T1, then plus C2 divided by which one? T2, plus C3 divided by T3. Close that, and we're doing the summation, so I should have not wrote this. So we're actually doing the operation. That's the operation we're doing there, and taking the whole summation of the values. So now let's plug everything in. So D equals 100% times C1. So C1 is going to be the 2.4, right? We put 2.4. T1 is going to be the value we got for 16, right? Again, I got this from the table for 85. So that's going to be 16. Plus the C2 is going to be the 3.6 hours. Divided by the T2, which is the 2. Plus C3, which is the 2 hours. Divided by the T3, which is 32. Right, T3 is 32, 32 for the 80, right? And C3 is the 2, right? C3 is the 2 on top. So now you close that and solve. So solving for D. So when you solve for D, you should get about 201.25%. So that one is way, way bigger than 100, right? 100%. That says, okay, we have to employ noise abatement. Noise abatement is required. So we know this is saying that is above 100%. It's above that threshold, basically that value for the threshold of 90. It's somewhere above here of that 90, and we have to employ that noise abatement technique because it's way above that 100%. So here we have to employ that, and one thing we can do is, like, if you look here, you can isolate the source. So you can do some barriers. You can also employ, well, in this case, you're looking at the machine. So you can substitute some gears, newer, quieter equipment. So this one would be a good one. And you can also, this is PPE, personal protective equipment, the earplugs, ear canals, ear muffs. But you would do this when you, like, have a conservation program, based on what's listed in the FE Handbook. So these are just noise control steps that I would read over as well. So in that case, it's going to be, the answer is actually the D, right? The answer would be D. And I want to quickly, one last thing, you don't have to watch this, we're basically done. The time weighted average, the 8-hour time weighted average is actually in this equation, right? But that's not in the handbook. But if we actually use this equation real quick, we can find the exact time weighted average with respect to that 90, with respect to the 90 for the noise level for a permitted time of 8 hours. So the time weighted average in this case, we just use that equation. You just take 16.61 times the log of what we take the dose on top. So the dose has to be in decimal dose. So I'm going to take the dose of 201.25 that we got percent divided by 100. I reduce the percent to a decimal, right? Then you close that and you do plus 90. Then when you solve for that, you get the time weighted average to be 95 dPA decibels, adjusted here, the A for adjusted in terms of like the human hearing, right? For humans. So that can be 95, and that makes sense. It should be above 90 because we got this dose to be above 100. And remember, when we have 100, that corresponds to 90 dPA. So this 95 logically makes sense because it's above 90 because it's around 201, right? Around 201%. So that's the time weighted average equation, and I want to know that's not in the handbook. This time weighted average is not in the handbook, but it's good to know that that's like the formula when you want to find the exact dose with respect to the 8-hour time weighted average, where we have that 90 decibels for the noise level. I believe that's it. So I didn't really talk about this stuff, but it's just looking at the sound pressure levels, different sound pressure levels, and this is also applicable to the task and the average noise level. And this is just good to look over if you want to pause the video and look over how like different equipment, different tools and so on have a higher, well, the highest is the worst, right? High noise level is the worst, and this is just for different tasks and tools, and this is just for sound pressure levels and decibels. Sound pressure is in pascals, but we usually use units of decibels, right? And I think that'll be it for this. Thank you.